Hi everyone, I am Raji from SNS College of Technology in the Department of Artificial Intelligence and Machine Learning. In my last lecture video, we have already seen about what is supervised learning, and under the supervised learning, we have seen the linear model for regression and classifications. The basic thing we have already seen in last lecture video. So today we are going to see about univariate linear regressions, which is the prediction of rain using temperature and other factors. That is, it is determining the market trends, which is used to prediction of road accidents due to rash driving. So by using the linear regressions, we have used to split the data by using the straight line, right? So for the given data sets, we have to split up the data into training data and testing data, which is independent variable or which is dependent variables. We have to split by using this straight line. So this linear regression shows the relationship between the independent variable x-axis and dependent variable y-axis, hence called linear regressions. So the line equations we have already seen in mathematical equations for linear regressions. For y equal to ax plus b. Here y is a dependent variable, that is target variables, and x is a independent variables, that is predicted variables, and a and b are the linear coefficients. By using this line equation formula, we have to finding the x-axis and y-axis. And the next thing is terminologies related to the regression analysis. That is dependent variables. The main factor in regression analysis which we want to predict or understand is called the dependent variables. It is also called target variables. In independent variables, the factors which affect the dependent variables or which are used to predict the values of the dependent, which is variables are called independent variables and also called as predictor. For dependent variables, it is also called for target variable, and independent variables which is also called predictor. And outliers is a observations which contains either very low value or very high value in comparisons to other observed values. So an outlier may hamper the result, so it should be avoided. So this is the outliers. And underfitting and overfitting if our algorithm works well with the training data sets but not well in test data sets, then such a problem is called as overfitting. For example, if we train the model means by using the data sets, the training data sets is not well in test data sets, this problem is called the overfitting. And if our algorithm does not perform well even when the training data sets, then such problem is called underfitting. In testing data sets, by using the training data sets, it will not work for on test data sets is called overfitting, and it will work for in training data sets, and it will not work for in test data sets, which this problem is called underfitting. So this is the basic difference between overfitting and underfitting. And the next thing is we are going to see about the case study examples for employee salary predictions. So imagine you are studying the relationship between years of employee experience X and salary Y using linear regressions. The intercept would represent the predicted salary of an employee with 0 years of experience. For example, a baseline salary of 30,000, and a slope would indicate how much the salary increases for each additional year of experience. For example, a slope of 2000 means each additional year of experience adds 2000 to the predicted salary. An example of equations is predicted salary is 30,000 plus 2000, that is years of experience, which is multiples of years, multiple of years of experience, that is 30,000 plus 2,000 into 21, which is equal to 72,000. And The next thing is, the given data set is experience in a year, that is X, and salary in K, that is Y, which is 8 years of experience we have a 10k salary, and 10 years of experience we have a 13k salary, and 12 years of experience we have a 16k salary. Then how much will worker with 20 years of experience be paid? This we have to find by using the line equations. So for example, we have to find the slope and intercepts by using this summation n into summation xi yi minus summation xi into summation yi by n into summation xi square minus summation xi whole square. So this is a slope for a slope of m, and intercept b is equal to summation yi minus m into summation xi by n. So the final equation is y is equal to 1.5x minus 2. So this is the slope equations formula. So next class we are going to see about how to implement linear regressions using scikit-learn. Thank you.